Before you go into the first exam walkthrough on the magnetic field chapter, let's talk about two things: circular motion and magnetic fields, and electric field and magnetic field. Okay, so we can see here a beam of electron is deflected as it crosses a magnetic field. The magnetic field is into the page and is represented by the cross dot here, right? And we can see that the angle between the velocity of the electron beam and the force is 90 degrees. They're perpendicular to each other, the force and the velocity. And this type of property we can see exhibited in circular motion. When an object is moving in a circular path, the force and the velocity form a 90-degree angle. They're perpendicular to each other. So here we can say that the magnetic force is equal to the centripetal force. The centripetal force is the magnetic force basically. Okay, and we know that the magnetic force is going to be BVQ and sine theta, and then the centripetal force is mv square over r. Now the sine theta here is going to be the angle between the magnetic field and the velocity of the charge. So we can see the velocity of the charge is going to be, let's take this position for example, it's going to be this way. It's going to be the velocity of the charge, and the magnetic field is going to be into the page. So we can see that they form a 90-degree angle as well, right? So the magnetic field and the velocity of the charge are going to form a 90-degree angle. So hence we can say BVQ sine 90 is equals to mv square over r. Okay, so sine 90 is just 1, so that gets out of the equation. So we have BVQ is equals to mv square over r. This v is removed, this 2 goes away. We're left with BQ is equals to mv over r. And then we can make r the subject, so r is going to be mv over BQ. Now we can simplify this expression further by saying that mv is just the momentum, so momentum over BQ. Okay, so that's the equation that we got. So the equation r is equals to mv over BE, where E is the charge of the electron, shows that faster moving particles move in a bigger circle because r is directly proportional to v. Particles with greater masses also move in bigger circles because r is directly proportional to m. And particles with greater charge move in tighter, smaller circles because r is inversely proportional to q. And a stronger magnetic field or greater magnetic flux density makes particles move in tighter circles because, again, r is inversely proportional to the magnetic field.